Hi folks, this is tutorial number 17, which deals with performing a very simple calculation for a mechanism which involves Coriolis acceleration. Now, this is done in the 3D Experiences release 2025x, and it goes into the playlist which says kinematics with 3D Experience. The problem that we have is an arm that is rotating about the base, and on it there is a cylinder that is traveling with a constant speed along the arm. It's a standard problem that you do in a dynamics first year dynamics class where Coriolis acceleration is introduced. Okay, so what I'm going to do is let me remind you what Coriolis acceleration is. When you have an angular velocity of the arm and a relative velocity of v along the arm, the Coriolis acceleration is the cross product of omega as a vector and v as a vector, and there's a 2 in the front of it. Now, if you look at the magnitude of this, it's going to be 2 times the angular velocity of the arm and times the velocity of that cylinder which is traveling on that handle. Now, for example, if I assume that the arm rotates at 60 RPM or 2 pi radians per second, and the velocity of the arm is say 6 inches per second, the magnitude of the Coriolis acceleration, which is magnitude of this vector, is just multiply this out with 75.4 inch per second squared. And of course, the fictitious Coriolis force is just the mass of the particle being that block times this acceleration. All right. So here are dimensions that I'm going to be using, although I'm not going to check my calculation against the theoretical calculation that I just showed you. Therefore, you really have to know where this thing starts from, and it's not very clear what the radius of the stand is. So it really beside the point. I'll make the arm about 15 inches long and proceed with the problem. This is the content of chapter 11 of the textbook that was done 9 years ago, and because it's not updated, instead of revising the book, I decided to do these video tutorials. That's chapter 11. Okay, so let's go ahead and make it. First, I'll do the base. Right click, insert 3D part. I'll make a base which is about maybe 1 inch diameter. Okay, so let's wait here. Okay, I'm going to rename this thing to be properties so that it says base. That base is stationary, that really does nothing except for making a revolute joint there. So let me go make it, double click on it. Okay. So let me make it on that horizontal plane. I will sketch a circle of diameter 1. All right, exit and pad it. Okay, so that's going to be, I'll make this thing 0.5. So this is going to be my base. Okay. Now I'm going to make the arm. So right click, insert 3D part. I'm going to go to properties and make this thing arm. And arm. All right, let's go make it. Double click on 3D shape. On a convenient plane, let me make that same, convenient for me is, is right here, this plane. Okay, sketch. Let me make a circle of diameter 0.5. Okay, exit. And pad it for a height of in the other direction flip the direction and make it a little bit taller, maybe 1. Okay, and then we need this handle sticking out of that. That's this piece. Okay, so let me go ahead and do that. So on that vertical plane, I will sketch a little circle here. The diameter of that circle, I'm going to make it also 0.5. Yeah, 0.5. If needed, we're going to make the appropriate changes. Okay, so exit. I don't like it, that's too big. Let me make this thing 0.25. I'll make it 0.3. How about that? Oh, okay, 0.3, and then another circle inside of that. Well, actually, that is never mind. That we don't need that. Okay, exit. Exit and pad this thing by 15 inches or 16 inches. There. Okay, notice that these two are the same part. So, for example, I can go here and change the color of that to a different color if you want. So let me do that for a second. Graphics. Let me change the color to, for example, orange. There, you can see that. Okay. This is all same part. Okay, good. Now we're going to go to the cylinder, the block that's traveling there. So we see now insert 3D part. Okay, let me call this thing the block or the cylinder. Cylinder. And that one is also cylinder. Let's go make it. All right, so on a convenient plane, and this is convenient for me, I'm going to sketch a circle that size. I know what the radius of that thing is, but the easier way is probably to project that instead of drawing a circle. So where is that project? So I'm going to select this circle and project it. Notice that it's projected there. And now add to that another circle. Okay, the actual size of it doesn't matter. So exit and then pad it. Okay, that's going to be the other piece. Okay, so all the pieces have been made. Let's go ahead and assemble these things. First of all, these are not assembled. Let me show you that they're not. Let me move things around. So we go under, for example, manipulate. Let me translate this thing in the direction, I don't know, maybe Y. And this one also in the direction Y. Okay, good. Now, we put assembly constraints here, so let me fix that base. So we go to engineering connection, fix, and that is going to be the base is fixed. Okay, now that goes on top of this, and there's a revolute joint. So let me go to revolute. Okay, revolutes and revolute. This is my favorite way of doing it. So axis to axis, plane to plane. So this axis to that axis. Okay. This plane to, let me hide that. I'll turn it around. I don't have to hide it. There you go. I'll rotate this, take that. And for controlling it, because later on we're going to put some physics into this. Later on it's going to be vertical plane of this and a vertical plane of that of that base. Okay, so for vertical plane of the base and vertical plane of the arm, doesn't matter which one. And then right now it's 90. No, it's not right. It's not right. Clear this. Select the XZ plane. Where is that? This is the XZ plane. Yeah. And this, I didn't want it to be. Let me clear this one also. Let me make sure that they're both XZ plane. Yeah. Good. If I put it 0, then it's going to turn back to where it was. Fine. Now I'm going to say OK. And now I'm going to make a prismatic joint between this and that. Okay, so let's go ahead and do that. So prismatic. I'll do line and line, plane and plane, and then controlling the length as some distance from somewhere. Okay, so let me see for a second. What I want is, for example, this one. I can use this. Really doesn't matter. This one and that one. And the vertical plane of the arm. So YZ plane of the arm. Make sure that we get the right one. Nope, not the YZ plane. Clear that. Clear it. Okay, so how about the XZ plane of this and the XZ plane of the arm. And because of the way I did it, it makes sense. And for how I measure the offset, I can go from the vertical plane, which is YZ plane of the, for example, the YZ plane of, the arm, and YZ plane of the cylinder. Yeah. Okay, good. Now, first of all, let me show you that we can actually, let me move this thing back. So here is manipulate, so translate. I don't like this thing. Okay, so along this direction, so I'm going to move this thing back there. It doesn't, I'm not particularly caring about where it starts from. But also, let me while I'm in this cylinder, let me create a point there, because later on we may want to plot the acceleration, which I'm not going to do it in this tutorial, but we need to set up a probe there, right? So, for example, going back to cylinder, you use a point, center of a circle, and you select that circle. So there's going to be a point created there, which we can use later on for plotting stuff if you wanted to do that, which I'm not going to do here. All right, so let's go all the way to the top. Looks like everything is okay. And the 2 degrees of freedom here, one is rotation of the arm here, and the other one is the prismatic rotation for the translation of this cylinder on that arm. So now we're going to go to mechanical system design, and mechanism. Let's create a mechanism. Okay. All right. And then let's check it out. Notice that there are 2 degrees of freedom. The revolute is angle driven because of those planes that I selected, and the the prismatic is length different. So that's good. How do we check this thing? So if you go to the mechanism player, there's going to be two sliding bars here. One of them is going to control the arm. The other one is going to be controlling the prismatic joint. So like that. This is the arm. Okay. And this one is controlling the joint. You see that? Okay. So reset all of them. Oops. I want to put it back where it was though. Oops. Okay, that's fine. Good. So we have the right ingredient. Now later on we're going to put some physics into the problem. So we go back, we go to the mechanical systems experience. This is where you create the physics. Okay, the other one is just basically cartoons and things like that. So this is say okay. It's creating simulation. All right. So I don't want to create a scenario. I wanted to cancel that. Let me show you how. I don't want to create the scenario automatically. I want to do it myself. So first, the physics of the problem. Click on the law excitation. There's two commands here. One of them is for the angle. The other one is prismatic. So I'm going to select the angle, and I'm going to say f of x, and this is going to be 60 RPM. Turn underscore minute. Or you can also type if you want, I don't know, 6.28 rad underscore second, or you can do DEG, 360 DEG underscore second, etc. So yeah, but I'll use turn RPM. So under time, multiply this thing by time. That gives you the physics of the revolution of this. And then do another one, another law, and that is for the second command here, which is prismatic, and I said equal to 6 inch underscore second times time. Time. Okay, good. Now we're going to go, oh, then let's do a probe here also, a probe for that location, that center point that I created, remember? So we go to kinematic scenarios. I created two laws or excitation laws, put it in there. I created a probe, put it in there, and let's do it over 2 seconds. So over 2 second interval and increment of 0.01. Say okay. Hopefully everything is fine here. So let's play it. Oops. Okay, the only problem is that, let's check that. Let me actually animate this, rewind it. Yeah, we can make it, let's put it back where it was. Back. Okay. So let me close this. Now, like this thing. All right, good. Okay, so let's go do some plotting here. So plot. I don't want everything. I want just the acceleration, magnitude of the acceleration, linear acceleration. And if you plot this, you're going to have actually both Coriolis acceleration and centripetal acceleration shown, because there is no acceleration tangentially, it's zero. There's a Coriolis acceleration and there is a radial acceleration or centripetal acceleration. So this will give you both of them. In other words, if you look at this, it's the square root of this thing squared plus r being location of where the cylinder is, omega squared. Okay, so you have to separate them. If you want to check the validity of this, you have to separate them, but I'm just going to plot it. Okay, so this is the magnitude of the acceleration. It is not linear. As a function of time, it is not linear, but there we are. So that's pretty much it. Good luck.